Hello everyone. Today in this video I want to show you how you can repair a laptop battery that holds a charge only for 10-15 minutes. We're going to replace the cells and reprogram the chip and make it working like brand new again. And we're going to do it thanks to this little magic box. It's the NLBA1. It's a professional laptop battery analyzer with chip reset functions. So the first thing that we need to do is we need to connect the NLBA to the battery. And for this, we need to know the pinout. As you can see, there are several different pins, and we have several different wires that we need to connect. But in order to have communication with the battery, you just need ground wire, clock, and data. How do we know how to connect? If we open the software, it's connected. The NLBA software has a great feature, and it's called battery pinout detection. It has a database, and I can say about 95% of the batteries are already in the database. So all you need to do is type your battery number. And here we have, this is the battery part number. And it's AS07A31. Let's see. And it does have the pinout. So I already know how to connect it. Let's take our ground wire. Connect it to minus. Take our data wire. We can see that the data wire is the pin number 3, and it's this one. Clock wire is pin number 4 over here, and we also need our positive wire to test the battery for charging and discharging, and we're going to connect it right here. So we can see that now the output LED of NLBA is on. That means that the battery is still working and the chip is not locked yet, which is good. So let's see what's the software going to show us. Let's start reading the dynamic data. Okay, the data is reading already. Let's read also the static data. Okay, we're going to stop reading. So what can we find as information? We can see, first of all, that the battery was produced 2009, so it's quite old. We can see the cells voltages because this is a 3S battery. It has 3 cells. We can also see how many cycles it had. This one had 232. We can see the design capacity. It is 4,400 milliamps, and we can confirm this by checking here, 4,400. What else can we see? Full charge capacity has already dropped a lot, 1,372. And that's why actually the battery is holding a charge 15-20 minutes. Current capacity is 75%, and the health is just 31%. So this battery needs a cell replacement in order to function again like brand new. And that's just what we're gonna do. So now we're gonna go to the bench and see the whole process. Okay, so we are at the bench already. First thing that we need to do, of course, is to open the battery. To open the batteries, I use a tool like this. You can improvise. Check on YouTube. There are many different videos about how to open a battery. You can use different tools, but I find this the most comfortable. This is a tool from a car trim removal set. You can find them on eBay. How are we gonna do this? We always start at the back, because in the front here is a PCB and we don't want to damage it. So always start opening from the back. We insert our tool into the crevice here, push in, and the battery has already started to open. Okay, we've cracked the case. Once you get to this stage, things are already very easy. Just push your fingers inside and spread the case apart, slowly and carefully, not to break it. Okay, and we continue forward. Again, fingers inside. And the last step. And there you have it. The battery is open with absolutely no damage. Now we need to remove the cells in the PCB. We insert our tool underneath the cells because there's glue underneath, and we slowly work our way up. See? There's this double-sided sticky thing. Alright, let's put the case aside for now. Let's see what's going on here. First, let's identify the chip. We can see that our chip is BQ8030. This chip is fully supported by NLBA for reset. Next thing that we need to do is we need to remove the cells from the PCB, since we are going to replace it. But before we do so, you have to be careful with these two. These are the temperature sensors, and they can be damaged very easily. So first you need to free those because they are glued to the cells with silicone. For this, I will take a knife, very sharp, go underneath. First one is free. Then we're gonna do the second one. Be very careful. And the second one is free. Now what I like to do is cut off all the cells connections. Always start from the positive. As you can see, this is the positive, this is the negative side. When you disconnect, always start from the positive. When you connect, is the reverse order. One is gone, second one is gone, third one, and fourth one. So these are the old cells that we don't need anymore. Let's put them aside. Now we are left with the PCB. And we have to clean up. I always get rid of the original wires. I use my own wiring. It's just easier for me. Another important thing, we have to check the fuse. We know that our fuse is good because our battery was still working when we disassembled it. But how can you check the fuse and how can you identify the fuse? This is our fuse. They come in two different shapes. 4-leg, this is the 4-leg fuse, and there are also 3-leg fuse. How can we check this one? The easiest way, remove this black cap and visually inspect it. Cap is out, and we can see that our fuse is still whole. It's not broken. If it was melted, this line here in the middle would be interrupted. But we can see that this piece is still whole. So our fuse is fine. That's the easiest way to check it. So moving on. As I said, let's clean up the PCB. Remove the old tabs. Can get a little loud from the fume extractor. Let's get rid of this one. Out. This one too. Out. These two wires. Out. And out. Okay, so our PCB is clean. Next thing that we need to do is to get our replacement cells. There we go, 6 cells. We're gonna spot weld them and then reattach them to the PCB. Okay, so we are ready to start spot welding. Here I have a little homemade invention, DIY, for holding the cells. It's important that the cells are absolutely straight, because otherwise you won't be able to fit them back in the case. Yes, there are these fancy magnetic holders, but I don't like them because they don't do the job properly. And as you can see, perfectly straight. DIY. Almost everything in the laptop battery world is DIY. We take 0.15 millimeter nickel strip. It is more than enough for a laptop battery because the currents are not so high. Even 0.010 is enough, but I use 0.15. So let's cut out our first piece, measure it out. This is going to be our positive connection. Two spot welds per side are enough. Let's measure out the second piece. Now we will flip the cells so we can do the other side too. As you can see, this holder is doing a perfect job. Okay, measure out here. Okay, don't need this anymore. So this is gonna be our configuration. 3S2P battery. Next thing we need to spot weld on the cells is some tabs for the voltage monitoring. Let's see how we're gonna do this. We take a few pieces of nickel, cut them off. And we're gonna cut them in half, like so. Okay. And we're gonna spot weld them right here. Always use the negative side. The other negatives right here. And we're gonna need one for the positive. And on the positive side, we need to isolate it. Just to prevent any shorts. The cell has isolation, but a little bit of extra protection will not hurt. Okay. Now we are ready to start assembling the battery back. So let's start the assembly process. What we need to do now is arrange the cells so they can fit in the case. As you can see, that's the original configuration, and we need to do the same. Let's do it like that. And like that. So let's put the battery back in the case to check the orientation. Where is the positive? So here's the negative. PCB goes in like that. Perfect fit. What we need to do now is run some wiring. As I told you, I always get rid of the factory wiring and I use mine. Much simpler, much faster. So let's measure it out. The first wire that we need is for the negative, and we'll go here, cut Get it out. Put it on the side. Second wire that we're gonna need. Let's go in here. Third wire. Yeah. Third wire will go here. And the last one is our positive wire. And it needs to go right here. Okay. First, what we're gonna do is we connect the wires to the PCB, and then we're gonna connect everything back to the cells. So let's start with the negative. First, of course, we need to strip it. Add some flux. My soldering iron is still hot, cold, it's okay. Yeah, there we go. Film extractor, I forgot it. Let's put it where it belongs. Right here. Next one. Next one will go here. Next one. Okay, we don't need this holder anymore. Next one goes here in the front. The last one is a positive. And it needs to go right here. Okay, so we are done with this, and we're getting closer to the end. Let's put the PCB back in the case. And now connect everything to the PCB. Pretty thin, nickel. Connect the negative first, like we said earlier. Okay, that's done. Then the next connection point. Done. Next one. It's also done. And last one is the positive. Okay, so we are done. That was the whole process of replacing the cells. But now we need to go back to the NLBA software and finish with the most important process, which is reprogramming the chip. So let's close the case. I will not close it perfectly for now because it's just for testing. Later on, when we finish with everything, we do the calibration cycles and so on. We make sure the battery is working fine. We're gonna close it properly and glue it all back together. Okay, so we are back with the NLBA device and the software. Battery is connected already. Let's try to read the data now. It's reading fine. And as you can see, all the parameters are still the old ones because they are still written in the chip's memory. You can see cycle count is the same, full charge capacity is the same, it's still very low. The health is the same, 31%. So what we need to do now is reprogram the chip, let him know that the battery has been recelled, all cells are replaced. We're gonna set the new capacity, we're gonna change the date, we're gonna change the cycle count, and we can do this from the reset tab. We go to new reset, read the SBS report, click next. Chip is auto detected. If you remember, the chip was BQ8030 indeed. Then we need to press next. First thing what we need to do before you make any changes to the flash memory of the chip is to read the original one and save it. So the EEPROM is read already. We're gonna save it somewhere on the desktop and we're gonna type original. Okay, now we can already make changes to the chip because if something goes wrong, we can write that original dump back. As you can see, today's date is already auto set, cycles, and the full charge capacity. What we're gonna change is the full charge capacity because our cells have bigger capacity than the original ones. They are 2600 milliamps. So we need to put full charge capacity 5200. And we're gonna write that to the chip by pressing write. Process is done. Can confirm this. Let's end the reset, go back to the initial screen and check the results. Start reading. Okay, everything has been successful. And what do we see now? Full charge capacity is like we chose it, 5200 milliamps. Cycle count is 1. Production date is the current date today. It is the 8th of February 2022. So this battery now is considered as brand new from the factory, and it will work as brand new from the factory, and it will hold a charge with this capacity for approximately 2-3 hours. Next thing that we need to do is run the auto cycle so the chip can relearn its new capacity. This is also very important, and we can verify that the battery is working correctly. This process takes a long time. Sometimes it can be 5-6 hours. It needs to fully charge the battery, fully discharge it, and fully charge it again in order to measure the actual capacity. So I will not be showing you this process because there are plenty instructional videos about this on the NLBA website and on the forum. There are step-by-step tutorials how to reprogram different chips, how to run auto cycles. The support is great. I can say if you have any difficulties, you just ask your question on the forum, and within a few hours, sometimes even a few minutes, you will get an accurate answer. So this was about it for today. I just wanted to show you how this great device performs, because there are plenty of positive reviews on YouTube, but they just show the charging and discharging functions and what the different parameters mean. But I wanted to show you a real repair video so everyone can see that it's not so complicated, and with practice it takes like 20-30 minutes per battery.